I looked at the paper on effects of beta hydroxy beta methylbutyrate, also known as HMB, on exercise performance and body composition across varying levels of age, sex, and training experience as a meta-analysis review. And these are the researchers. Um, so just as some background, so I know in our last unit, we talked about leucine and kind of just that pathway that it takes to get turned into just various other things. So I pulled this from the last slide. So leucine gets turned into alpha ketoisocaproate. And then from there, about 95% of it gets turned into isovaleryl CoA, and then about 5% of that is going to be turned into that HMB. So just as kind of a reference, you would have to consume around 60 grams of leucine to get 3 grams of HMB, which is just the most common dosage. And then HMB can be found in grapefruit and catfish, just some examples of food. So HMB is commonly used as an ergogenic aid. So it's used to increase performance and recovery in people whenever they're exercising, typically, and also sometimes in other cases, just in people that are having issues with muscle degeneration. Um, and then the research has also looked at HMB results in untrained individuals, trained athletes, and the elderly. And so they looked at measuring a lot of different aspects. So some examples were delayed onset of muscle soreness, blood pressure, immune cell function, cholesterol, and just other things that we'll talk about later. So the objectives of the study were to provide an in-depth and objective analysis of HME literature, and then they took special care to present critical details of each study in an attempt to explain possible reasons for the conflicting results seen. And then they also had another goal of providing an in-depth analysis of the possible mechanisms that HME may exert its effects. And then just the areas that they considered include HMB's capacity to prevent muscle damage, lower protein degradation, and directly stimulate protein synthesis. So just kind of in a nutshell, there's been a lot of research done on HMB. However, it's been done on so many different groups of people, like trained, untrained, elderly, and then different numbers of amount of people. And then they also measured it a bunch of different ways. And so we have all this information, but we don't have a very clear idea of what does it work or does it not work, just because there's so many moving parts with that. And so that kind of goes to that first objective of figuring out like, why are we getting conflicting results? What's contributing to that? And then also, assuming it does work, why is it working? What's going on biologically with that? So that is kind of just an overview of what this study is looking at. So these are just some measures that were used to study the HMB supplementation. So the main ones were dynamic, isometric, and isokinetic strength, functionality exercise, and that was more in the studies with the elderly. Questionnaires on delayed onset muscle soreness, blood pressure, cholesterol, immune cell function, and then also markers of muscle damage. And so this is a table that they included in it, and this just goes over just all the research that they looked at and the participants who was in it, the dosage and duration, like how much did they take and how long were they doing it for, and then just the biochemistry behind it, and then performance and body composition. So you can see table 1 looks at the studies that supported HMB supplementation as like working, and then table 2 is more of the studies that don't really support that it works. So as you can see, there does seem to be more research that suggests that it works. However, there are just some of these studies that are saying it might not work. So that's just kind of what it looks like, just kind of an overview of all the different papers that they looked at. So just as an example of some of the results that were found on untrained individuals, so there was one where participants ingested HMB in quantities of either 0 grams, 1.5 grams, or 3 grams. And then they lifted weights 3 times a week for 3 weeks. And I think it was for an hour each time. And then they found that H&B decreased plasma markers and protein degradation between 20 to 60% when they were comparing to those that were not taking H&B. And then the amount of weight that they were able to lift also increased with each dose. So in a second experiment with the same study, they increased it to 2 dosages of HMB a day, and then it was either 0 grams or 4 grams. And then the weight training was 2 to 3 hours a day, every day for 7 weeks. So lean body mass had a great increase, especially compared to experiment 1 at weeks 2 and 4 and 6. And then the non-HMB group had increased their 1 rep maximum by average of 5 pounds at end of 7 weeks. And then the HMB group increased by 15 pounds at end of 7 weeks. And I just realized I don't think I talked about the hypothesis part of this assignment. Since this was a meta-analysis, they didn't really list a hypothesis just because they weren't really conducting an experiment. They were more just looking at everything. So that wasn't really included in this paper. So as some results on trained individuals. So on an experiment that was suggesting that HMB worked, it consisted of 36 men and 36 women, and they all had various experience and training. And they found at the end of the study that the HMB group had a greater body fat decrease and greater increases in lean body mass and upper body strength. And then there was actually a study that suggested that it didn't really make a difference, and that consisted of 40 athletes experienced in resistance training. So they did 7 hours per week for 28 days. And they were they were divided up. So some took 0, some took 3, and some took 6 grams of HMB daily. But they weren't monitored, and they found that muscle damage, fat mass, and lean body mass did not have significant changes. And so that is something to note, that they weren't monitored. And this was one of the studies that is suggesting that HMB doesn't really make a difference. So it is just something to note. I noticed that all of the studies are suggesting that it doesn't work. We're all in trained individuals, so there's not really a lot looking at there's not a lot of research suggesting that it doesn't work in untrained individuals or the elderly. However, most of the research has also been done on trained individuals. So just as another example of the elderly individuals. So 3 grams of HMB were taken daily for 8 weeks in a 70-year-old population. They exercised 2 days per week, and they had more fat loss in the HMB group. And then another study consisted of 35 to 70-year-olds over a 12-week period. And then it kind of worked, kind of didn't work in this study. So the leg extension, walking time, and chest press were not found to have a huge difference when compared to the placebo. However, they did a sit-down exercise, and that did improve with the HMB group. And so this is just kind of another area where you kind of see there's just so much variation, because that first one was in only 70-year-olds, whereas this second one is in people that are 35 to 70-year-old. So that is a 35-year age range, and it also happened for an extra month. So again, just a lot of variation going on in this area. So the paper also discusses, is HMB harmful? So many people are consuming more than the recommended amount of HMB, which is 3 grams per day. But research in humans and animals doesn't really seem to suggest that there's an adverse effect in high dosages of HMB. There was a separate meta-analysis done that was very similar to this one, but it combined only 9 studies with individuals who were male, female, young, elderly, exercising, and non-exercising. which is the same as this study. And they didn't find any indicators of health to damage of tissues or tissue function. So another study looked at the effects of HMB in untrained men and did not find evidence for adverse effects. And the research suggests that HMB boosted immune cell repair and wound repair. So this is very exciting because there's not a lot of evidence that HMB has harmful effects, and it seems to do a lot of really cool things. So it also looks at digestive patterns. So there were two studies, and one had participants consume 1 gram of HMB, and then another had participants consume 3 grams of HMB or 3 grams HMB plus 75 grams of glucose. So 120 nanomoles per milliliter at 2 hours after ingestion was the HMB peak for that 1 gram of HMB. And then 487 nanomoles per milliliter 1 hour after digestion or ingestion for the was a peak for the 3 gram HMB just by itself, and then 352 nanomoles per milliliter after 1 hour in the population consuming 3 grams of HMB plus glucose was the peak for that second study. And so it was suggested that the delay in peak concentrations may be caused by increasing concentrations of glucose due to the gastric emptying being slowed. So we do see that it increases with HMB. However, when that glucose is added in, it does go down a little bit. And so looking at just kind of the conclusions that the authors came to. So as we saw, there was a lot of variability found, and this could be due to a lot of different things, and that includes sample sizes that were too small, just all the differences between each human, the way the method was carried out, overtraining and or inadequate training, lack of specificity regarding training conditions, short duration of experiment, and a limited number of dependent variables. There were several papers that supported the use of HMB to show improvement in the performance of a VLA and peak VO2 in athletes trained in endurance, and then lean body mass and strength in resistance trained athletes. So then delayed onset muscle soreness, body fat, and muscle damaging were also suggested to be decreased by the use of HMB. So researchers are particularly interested in the use of HMB to treat diseases that are associated with muscle wasting. So this includes AIDS and cancer, and then also for those that are in bed rest and just are more at risk for muscle atrophy. So HMB might also be helpful as a method of gaining control of blood pressure and decreasing LDL. So as I mentioned earlier, they were also wanting to look at just some of the mechanisms and like why HMB might be working and like how it does what it does. So they kind of summed it up as protective and anti-catabolic mechanisms. And that's what they're thinking is most likely going on. So one hypothesis that they have is called the cholesterol synthesis hypothesis. So this is based on a theory that an adequate level of cholesterol for cell function cannot be produced by muscle damaged tissue. So one of the functions that can occur is sarcolemma integrity, which is essential for muscle tissue. So a large percentage of HMB is converted to HMG-CoA, which is a precursor for cholesterol. And so they think that the HMB can function to provide the substrate needed for cholesterol synthesis so that sarcolemma can be formed and stabilized. So it's been found that when cholesterol synthesis is inhibited, muscular damage is impaired and muscle cell necrosis can occur, and there may be an increase in muscle damage. So the HMB is just kind of like counteracting some of that muscle damage that's going on potentially. So another thing that they're looking at is HMB and its association with the ubiquitin pathway. And we talked about this in our last unit. So I pulled this picture from a video that I watched a couple weeks ago, just because I thought that it kind of visually put together that ubiquitin pathway. So just as kind of a reiteration. So initially, there's this E1, and it has the ubiquitin attached to it. And so the E1 moves it to the E2 through transthylation. And then that E2 is initially not attached to the E3, but then it ends up attaching to the E3, as we can see. And then on the other end of that is ligase. So essentially what's going to happen is the E2 is going to kind of push that E2 forward. And so the red piece, which is the ubiquitin, will attach to that ligase, and then other ubiquitin will start to attach to it, and that'll eventually signal that some protein breakdown needs to occur. So the ubiquitin pathway plays a role in protein degradation and is associated with some conditions of a muscle breakdown, such as starvation, anti-gravity, denervation, and a lack of activity, among other things. So HMB is thought to interfere with the UB pathway and decrease protein degradation. So a study in mice with, I think G6 is the way that you say that, mice found that when they were given HMB supplementation, they had an increase in the weight of the gastrocnemius muscle and a decrease of or in protein degradation. So protein synthesis also increased in the gastrocnemius, which is just interesting, and there's less activity and expression of the UB pathway. So just some implications for future research. As far as the first objective goes, um, so this was a qualitative analysis, and so a quantitative review would be really great to follow this and just actually get some numbers that could be used to, I think, further clarify what's happening. And then the meta-analysis could also be more focused on specific areas. So as I mentioned, there's just a lot going on, a lot of different conditions of where people are in terms of like exercise. And then they're also looking at all these different markers to try and figure out, is this suggesting that HMB is having an effect? So just some things that they could potentially focus on are people with similar exercise level, training load, age, and then just looking at delayed onset muscle soreness, among other things. So the 3 to 6 gram dosage is also the only one that's really researched. So they might want to do like a little bit more looking at what happens when you have like higher dosages. And then also longer studies are needed since the typical duration for what has been done at this point is pretty much 4 to 8 weeks. There's not been a lot of like long-term studies that have been done. And then also it's just still with that first objective. So they've been doing a lot of research looking at the use of amino acids before and after workouts to increase protein synthesis. And so the researchers in the paper kind of talked about how they could use potentially HMB for that, like instead of amino acids or in addition to them, because there were a few studies that looked at HMB and leucine and like how that worked if you put them together. So just more on that. And then some research suggests that it doesn't matter if HMB is taken before or after workouts. So looking into that. And then it also has not been assessed with a loading period or with sarcolemma integrity. And then again, just looking at HMB over the long term. So as far as that second objective, which looks at like how is HMB working? So HMB is thought to be associated with cholesterol synthesis by inhibiting protein degradation, but it also has lowered cholesterol in some studies. So this might be due to calcium supplementation, but we don't really know. So more research on that. And then does HMB directly stimulate protein synthesis? We kind of know it has something to do with it, but is it direct or indirect? We don't really know. And then also just protective and anabolic mechanism is one of the most supportive pathways HMB exerts effects. So again, this is just kind of what we're thinking, but we're not really sure. And then those are just my sources.